The idea of our project is to create a maze solver. So in the maze, have a robot that is capable of finishing the entire maze by itself. So in order to do that, we created the states. The first state would be 000 with 3 possibilities. So we would use a counter to check which possibility is the best, or the correct one. The counter would be used as a checkpoint, so if there are more than 2 available spaces, because the third one would be the one that it just came from, the previous direction, which is called path 0. The path 1 would be the first new direction, the path 2 the second new direction, and path 3 needs to be blocked. Otherwise, it would be the end of the game, having all the 4 states being available, and the robot would be out of the maze. The second state would be 001, which means only one possibility, and this would reset the robot to the nearest counter, going back all the way to the last counter that it encountered. Another state would be 010, which would be 2 opposite possibilities, which means to continue in the same direction, knowing that one of the possibilities was the previous space that the robot was encountered. The second would be 011, not opposite possibilities, meaning a new direction upwards, and so on until the 110, which would be not opposites and the direction right. 111 would be 4 possibilities, all directions available, which would mean the end of the game. Here there are examples that you can understand more about our states. Here we have 3 possibilities, the previous space and 2 others, and then it explains that it needs to go up. If it went left, it would come over because of the checkpoint. And here you would see the case 001, it would hit a wall and have to go over all the way to the star, which is the counter checkpoint. Here is a change of directions, as it needs to go upwards, the case is 011. Here you need to go straight, so it's the same direction, 2 possibilities, case 010, and here all directions available would mean the end of the game.
So for the code, we were based on like previous examples we had in class. So we have a clock, we have a reset, so the robot can go back into the maze. And then we have the input direction and the output state. So how the robot would like understand the maze and like take action with the sensor inputs, so we can go to new directions. We have the parameters, and in each case we have, just like Thales explained, and here we have in each case which possibility the robot could take. So we've had the counter, the only possibility it could go to is in the opposite direction, opposite state, meaning that it needs to go forward. In the reset situation is the 001, meaning it's only one possibility, so it only can go back to the counter. And then the opposite state, meaning it can go into any direction, so it can keep going opposite, meaning forward, then it can go to the upward situation, downward, right, left. And then to the right situation, it can only go forward, upward, and downward, not left, because it is left meaning going backwards. That's not what we want. We want to get out of this maze. And the left is basically the same case but not going right. And then we go to the downward and upward situation, where it is similar to the right and left situation, but you cannot go back, meaning if you're in the downward situation, you can only go straight or right and left. And in the upward, it is just right and left, but not downwards. And in the end case, it does not mean which situation you have next. You're already out of the maze, so it means end game.